Hi everyone, we have another set of information for a triangle, and we're going to see if we can figure out how to use law of sines to solve this. So I'm going to start with a picture. So we'll just say, okay, over here in the corner, we've got a 36-degree angle, and that was my alpha. And then our second angle, and we can draw it either on the top ray or the bottom ray, is 24 degrees. Since I've already got this bottom ray extending out longer, I think I'll use that. I need something a little smaller than that 36-degree angle I drew. So if we make that a little skinnier, say that's maybe what a 24-degree angle looks like, and that would be my beta. And then the one side length I'm given is this b equals 4, so that has to go across from angle beta. So I have a side angle angle or angle side, however you want to look at that. And I should absolutely be able to use that to solve for side A. So I could say A over the sine of the angle opposite, A over sine 36, is equal to B, which was 4, over sine 24 degrees. And to solve for A, I'll just need to multiply both sides by the sine 36. And then this becomes a technology question. So use the calculator that you like. A scientific calculator is great. If you want to use the Desmos scientific calculator, that works for me as well. When I crunch numbers here, I get roughly 5.78. So I'm getting something a little bit, 5.78, longer than that B value that I had. You know what, I'm going to keep these labeled. And that seems reasonable to me. That 36 is a little bit bigger angle, so having a little bit longer side over there looks about right. I do still need to solve for angle gamma and side length C. So let's pick a different color. So this would be my gamma and my C. Gamma isn't going to be too much work. We have two angles, so we can always get the third for free. So we know that the angles add up to 180. Which means that if I subtract 36 degrees and 24 degrees, I should get that my angle gamma is 120 degrees. All right, and now if we want to go for side length C, we can set up another law of sines. I can say C over sine of 120 degrees is equal to, and we could use either A over alpha or B over beta. I'm going to stick with the B over beta because I did round a little when I calculated A, so I'd be carrying a little bit of extra rounding over here. It's probably nothing huge, but when you can avoid using that rounded number, I think it's smart to do so. Okay, so we just need to multiply both sides by sine of 120 degrees. And then this again becomes a technology question. So calculate that number. I got roughly 8.52. This seems like a decent answer to me. I know that if I flattened this top angle out right here, this one, all the way, that I'd have 4 plus 5.78, so almost 10, 9.78. So it's smaller than that. That's good. It should not get any bigger than A plus B. But it should be kind of close to that because this is a fairly flat triangle. It shouldn't be in the ballpark of A or B based on my not perfect, but sort of to scale drawing. So that's my solution. I've got all sides and angles of the triangle. And again, always try and do that reasonableness check. Look and see if you think you might have an ambiguous case here with the angle side. That shouldn't happen. That's always going to be a angle side or a side angle.